Alright, this is the Unit 7 test correction video. Question number 1. Riley owns 7 rabbits. She expects them to quadruple each year. This system is if we make a table, she starts with 7 and then it quadruples. Quadruples means times 4. So that would be 28. Next one would be 80, 112? If I'm doing my math correctly, you can type that in your calculator as well. But regardless, since you're multiplying by 4, it is exponential. So B. Write the equation that models the number of rabbits over time. So again, that would be y equals ab to the x, since it's exponential. So y equals the a value, which is 7, times the multiplier, which is 4, to the x power. And how many rabbits will she have after 5 years? Alright, well, I have my decimals open. Unfortunately, I can't share that screen with this program. But all I'm going to do is I'm going to type in y equals 7 times 4, and then the 5 I'm going to plug in for the x, so to the 5th power. So I'm going to type that in right now. Y equals 7 times 4 to the 5th power. And that turns out to be 7,168 rabbits. All right, you can fast forward, rewind, pause, slow down, whatever you need to do with the video so that you can get all these corrections made. Question number 2. You discovered 2 different types of monsters. One type starts at 34 pounds and grows at 20 pounds per week. The other type starts at 2 pounds and the weight multiplies by 1.5 each week. Write an equation for each monster. Let FW represent the first monster and GW represent the second. Alright, so I'm just going to fill out a table here before I write the equation. So the first one starts at 34 pounds and it increases by 20 pounds each week. So basically I need to add 20. So that's going to be 54. Add 20 again, 74, 94, 114. If I add 20 to that, and 134. Second one, it starts at 2 pounds, and it multiplies by 1.5. So that'd be 3. Alright, so this is going to be a little more difficult. So I'm going to have to do 3 times 1.5. And that turns out to be 4.5. Then I got to multiply that by 1.5. This is going to take me some time here. 6.75. Alright. Etc. So, I don't know, you can fill in the others on the table. I guess I might as well keep going. So 6.75 times 1.5, 10.125. And then I'm going to multiply that by 1.5 again. Whoops. Mistake there. 15.1875. All right, monster 1, what's the equation? Well, we are adding each time, so that's y equals mx plus b, because you add the same number. So therefore, it's going to be y equals, m is your slope, it's your growth, so it's 20, times x, plus your initial value. Your initial value here is 34, or your starting value. Monster g of w, okay, so that's being multiplied by the same number each time. So that's y equals ab to the x. So y equals the a value is your initial value, which is 2, times your multiplier, which is 1.5, to the x power. There you have it. Number 3. Suppose you own a piece of art valued at $7,000. The artwork is increasing, ooh, key word right there, at a rate of 6% a year. Write an equation that represents the art over time. So again, since it's increasing, I got to use that magical equation of m equals 1 plus the rate. Remember 6%, if I do 6 divided by 100, that's equal to 0.06. So I'm going to do 1 plus 0.06. So that turns out to be 1.06. So in the equation, I'm going to have y equals the starting value, which is 7,000, times the multiplier, 1.06 to the x power. How much is it going to be worth 6 years from now? So we're going to take the number 6 and plug it in for x. Plug that into decimals. Let me erase the other ones I have here. I know you can't see my screen, but I am typing in 7,000 times 1.06, and then all that to the, 6 power. Whew, it's going to be worth a lot of money. $9,929.63 if I round it. Round to the hundredths place, so that would be the nearest penny. Since my number after this is a 3, since that number is not 5 or higher, I keep this number the same. If this number was 5 or higher, then I have to move that one up. All right, part B, 2 parts to this question. Suppose you buy a Rolex watch for $22,000. It loses value, depreciates at a rate of 7. So then I'm going to have to use that magical equation of 1 minus the rate. So again, if I do 7% divided by 100, that's 0.07. So 1 minus 0.07. So if I do that, that turns out to be 1, what? Nope, not 1. It turns out to be 0.93. All right, so if I write the equation, y equals the starting value, 22,000, times 0.93 to the x power. Again, we're going to take the 7 and plug it in for x. I'll do that in my decimals program here, 22,000. Who would ever spend that on a silly watch? Crazy. 0.93 to the 7th power. And that turns out to be 13,237.41. Now I have a 9 as my next number. So since that number is bigger than 5, I got to round this one up. So $13,237.42. All right, next one. The population of bacteria is growing rapidly each day, increasing by 20%. There's that magical word again, increasing by. The original population of bacteria in day 0 was 110. Let X represent days and Y represent number of bacteria. So in this case, we do the magical equation of 1 plus the rate. I do 1 plus. If I do 20 divided by 100, that's 0.2. So I come up with 1.2 as the multiplier. So it starts at day 0 of 110. Then each time I got to multiply by 1.2. So on my calculator, 110 times 1.2 equals 132. That's for day 1. Second day, if I multiply that by 1.2, I get 158.4. Day 3, multiply this by 1.2 again. I get 190.08. 4, got to multiply it by 1.2 again. 228.096. And one more time to get the fifth one. 273.7152. Write the equation. Well, it is multiplied by the same number, so it is y equals ab to the x again. Sorry, I lost the camera here. Y equals ab to the x, so y is equal to the initial value, which is 110, times the multiplier, which is 1.2, to the x power. Right. Move on. Number 5. Certain radioactive material decays in such a way that the mass remaining after T years is given by the function of this equation right here, where m of T is measured in grams. Find the mass at time 0. So you could take this 0 and plug it in for T, or you could just realize that at time 0 that's the starting amount, which is 245. Either way, oops, you get the answer of 245 grams. How much of the mass remains after 25 years? So we're going to take the 25 and plug it in. So in my calculator, I'm going to type in 245 in parentheses 0.97 to the 25th power. So to the power of 25. Let me write that down in case you did not get me verbally. So y, plug this in, y equals 245 times 0.97, or you could do 0.97, that's fine, to the 25th power. And that number turns out to be 114.40, and then that next number is an 8. So notice that next number, because I am supposed to round the 2 decimal places, is higher than a 5. That means I got to round this one up. So 114.41. All right. Zhang inherited a book collection of 585 books from his grandmother. He made a promise to add 12 books to the collection each year. So if I make a table for this one, oops, make that X, make this Y. At time 0, there's 585 books. 1, we're going to add 12 more books. So that would be 597. 2, I got to add 12 more, so that would be, 609, I think, etc. Anyway, I'm adding 12 each time, so that makes a linear equation. Write an equation that represents, so that would be y equals mx plus b. M is your slope, so that's 12, so y equals 12x, and the starting value, the number you start with, would be 585. How many books will there be in a collection after 13 years? So I'm just going to take 13 and I'm going to plug it in for x, because x stands for the number of years. So I'm going to type that into decimals. 12 times 13 plus 585. 741 books. How many years will it take to be 945 books? So I'm just going to guess and check. Since 13 years was 741, I got to guess a number bigger than that. Let me just guess 16 years. That's 777. Ooh, that's way too small. Let me guess 25 years. That's 885. Let me guess 30 years. That's 940. Oh, right there, I guessed it. 945, 30 years. So just guess and check. Now you could do that mathematically. What you could do is you could use your equation, y equals 12x plus 585. And I know what my y value should be. That should be 945. So 945 equals 12x plus 585. I want to get x all by itself, so I'm going to subtract 585 from both sides. Let's see, I got to do some math here. I got to carry a 1, so that'd be 6. That's an 8. That'd be 3. 360. Divide both sides by 12. 12 goes into 36 3 times, and we still have the 0. Drop the 0 here, so that's going to equal x. Or you just, of course, type that in decimals. What is 360 divided by 12? All right, number 7. Moving right along. Write an exponential equation for the following. All right, we've done a number of these in class. Since it is exponential, I know it's going to have a multiplier, so I could take any of these numbers and divide it by the previous one, or I can just realize, hey, negative 3 times 2 is negative 6. So all of these must be times 2. All right, don't know why I did that. That's kind of a waste of time. I didn't need to know all that. But I do know that my y value should equal the initial value, which is -3. Okay, -3, -3, -3. This one's out. Times the multiplier, which is 2 to the x power. So it looks like letter C for this one. Find the equation from the table. So I'm doing exactly the same thing that I did before. So I can take any number, divide it by the previous to figure out if I'm multiplying by the same number. So if I do 7 divided by 70, that's 0.1. In fact, all of these are going to be 0.1. So it is exponential. So it is in the, oh, they even tell me it's exponential. They tell me what equation to use. Oh my gosh, this test could not be any easier. It's giving me like all the answers. All right, so I plug in my initial value, which is 70 for A, times the B, which is the multiplier, which is 0.1 to the x power. And that's it. That's all I got to do. All right, number 9. Remember we went over this one in class on Thursday. Mr. Zimmerman did not know what this was. I'm going to put the video on pause. I have somebody at my door right now, so hang on one second.